just a boring square. I wish I was an octagon, but I am just a square. If I was an octagon, then I wouldn't care. My sides would equal 8, and that would be just great if I was an octagon and not a square. I've always been a square, and it just isn't fair, because I've wanted more than sides that equal 4. Na 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 na, just a boring square. I wish I was an onagon, but I am just a square. If I was an onagon, then I wouldn't care. My sides would equal 9, and that would be just fine if I was an onagon and not a square.
So, you want to have more than 4 sides?
Is it possible?
Anything is possible for Dr. Polygon.
Oh, what are you doing?
Bisecting the diagonal by the square root of the hypotenuse.
Please, no, not that.
Ah, you squares are so obtuse. There, all done.
Well, now I am a decagon and not a square. Now I am a decagon and very rare. I won't complain again, 'cause my sides equal 10. I am a decagon and not a square. When I was just a square, I thought it wasn't fair, so I had surgery to my geometry. Now look at me, na 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 na, not a boring square.
Well, there you go. There's the conclusion of the Just a Boring Square song. Poor guy. It's just funny where he's behind the curtain. No, none of that. All right, well, we're going to go ahead and look at three-dimensional figures in 11.4. And we're going to be looking at classifying some solids and describing some cross-sections of these. First, let's look at a little cartoon. So here's one on the far side. You're crying out loud, Warren. Can't you just beat your chest like everyone else? He's doing the armpit thing. All right. Let's get into looking at these different solids here. Classifying solids. So on page 331, we're going to see three-dimensional figures or solids are bounded by flat or curved surfaces that enclose a single region or of a space. So the first vocabulary is a polyhedron. So a polyhedron is a solid that is bounded by polygons. And so you have all these things called the faces. The faces are all like the sides. Basically, you can just say that, write down for faces, that's the sides of your solid. And that all the sides would need to be polygons in order for it to be a polyhedron. An edge of a polyhedron, so where it says edge on your vocabulary, that's a line segment formed by the intersection of two faces. So we have an edge, right over here between these two. So you got this polygon, which would be a trapezoid. You have this polygon over here, which could be a square or maybe a parallelogram. It's probably a square. And so that forms an edge right there, a line segment of those two faces. You have a vertex of the polyhedron. That's just a point where the three or more edges meet. So that's going to be kind of a corner point there for that solid here. So you got this edge down here, and this edge all coming together at that vertex of the thing. But the main thing about this is that you need to see that the faces have to be polygons, which means they can't have any curves. Polygons do not have curves. So this core concept definitely puts it into two categories. One where you'll have a polygon, and another thing I didn't read to you, but basically the plural form of a polyhedron is a polyhedra or polyhedrons. So when you see polyhedra, that just means more than one polyhedron, and then not polyhedra. So these are not polyhedrons. So you can see the different types, the two different types here of these is that the polyhedra is has all the faces being polygons, and so there's no curves here. Over here we have a cylinder that's got curves, a cone has curves, and obviously a sphere has curves. So this would be not polyhedras or polyhedrons. So a cylinder is not a polyhedron because of the curves. But these two are polyhedrons because these are just all, rigid kind of shapes. There's no curves on them. So let's look at these three here to tell whether each solid is a polyhedron. So letter A right there, there's no curves. So if there's no curves, it would be a polyhedron. It says name the polyhedron. So we can name it here. It says, so it is a polyhedron. It's called a rectangular prism. And that actually goes back to over here. We should look at this again and see we have prisms and pyramids. So you have either one of two types of polyhedrons. You're either going to have a prism or you're going to have a pyramid. And you're going to give it, that's like the last name. The first name would be, this would be a rectangular prism right here on this one because the faces are rectangles, or like the base of these, more thinking about the base as rectangles. This would be maybe a square pyramid possibly, or a rectangular pyramid. If this is a square down here on the base, you could say it's a square pyramid, or if that's a rectangle, it's a rectangular pyramid. So that's why they said over here that this is a rectangular prism, because the base would be a rectangle. You can see the faces here are all rectangles. And this one also on letter B is a polyhedron. There's no curves. But look at the base here. This base has 6 sides, so that would be a hexagon right there, base. And so you'd call this actually a hexagonal pyramid. So it is a pyramid, because you can see it's the pyramids going up here. The sides here end up being triangles that go up to a point at the top, so it makes a pyramid, hexagonal pyramid because the base is a hexagon. C is just not a polyhedron because you have your curves. That would be a cone. Cone has got a curved surface, so it's not a polyhedron. Okay, so there on your extra practice 1 and 2, just tell whether this is a polyhedron, and if it is, then give it the name of the polyhedron. So number 1, you should notice that this is a polyhedron. There's no curves on this. And so we want to see, okay, what kind of polyhedron is this? This would be an octahedron. So it's actually not going to be a pyramid or a prism on this one, because it's actually, this is really formed by 2 prisms. So when you put 2 prisms together, you end up with 8 sides now. So you have 4 sides on top, and you have this square down here. So that's where you can see definitely got 4 sides going. And you're putting 2 of them together, so that makes an octahedron then when that happens. When you're putting 2 pyramids together, see how many sides you have. We've done one of these before in the origami. I think we actually did a hexahedron, because we had 6 sides on that one. Number 2, you can see on this one like an inner tube right here, that shape, that is not a polyhedron, just no. Tell whether it's a polyhedron? No, it's not, because of the curved surfaces. Okay, back on your vocabulary, 331, for cross section, there you want to write down a cross section is the intersection of the plane and a solid. A plane and a solid. So you have a plane here, it's kind of like a pink color, and then you have your solid, and if you were to slice through your solid with this plane, it creates a cross section that's kind of here in purple. And really what you want to do is just kind of describe what shape that cross section is. So you can see on this one the shape is a square. It almost looks like a parallelogram, that's just because of the way the drawing is, but it really would be a square. This one, if you cross-sect this one, now these are all cubes, by the way. So it says 3 different cross-sections of a cube are shown below. So that's why this has to be a square. If you go straight flat through it, that's going to be a square. If you go at an angle this way, you end up with a rectangle. If you just go at the corner over here, you end up with a triangle on this one. So there's 3 different cross-sections where you get 3 different types of shapes on those cross-sections. All right, let's take a look at these and just see these. There's 6 of them here. Let's look at how we would describe the shape formed by the intersection of the plane and the solid. So on A, we're looking at describing the shape of the purple part. So that's just 6 sides. That's just a hexagon on that one. So you can see the cross section's a hexagon for A. On B, you can see this one is a triangle, so it's a triangle for B. For C, on this cylinder, if you cross-sect this would be a rectangle right there. So a rectangle for C. This one is another circle. If you just cross-sect the cone that way, it's going to end up with a circle. You cross-sect the this sphere, this kind of ball shape, straight down. That's going to also give you another circle cross-section. And then this one, if you cross-sect, I don't know, this might be a possibly a cube here. But if you cross-sect it, what do you get? Well, the top part is more or longer than the bottom part, and so you end up with a trapezoid on this one. So a trapezoid cross-section. Okay, so for 3 through 6, go ahead and just pause the video and do your best at describing the cross-section formed here, which is the darker gray part here in the middle. So try to figure out what shape that is. Go ahead and try to describe that shape of the cross-section. Okay, you should have paused the video, and now let's just check to see if you were able to describe those cross-sections correctly. So this one here, it's going straight through this pyramid, but it's got a square down below here, so it's going to end up being a square for your cross-section. This one's going straight down through the pyramid, same kind of pyramid it looks like, but it's going straight down. So that one's just going to give you a triangle. You can see there's a triangle, 3 sides there. This one has got 1, 2, 3, 4 sides. On this one for number 5, where did I put this one? There it is. So it is a trapezoid. You can see it's got longer, these two are your bases here, so this is going to be a little bit longer than this one. It's a trapezoid. And then this one we have some sides here. You got to count up the number of sides of how many we have. So 1, 2, 3, 4, 5, 6, 7. It looks like it's a heptagon. 7 sides is a heptagon. So there you go with those. All right, a little joke of the day is, what do you call someone without a body or a nose? Nobody knows. Okay, wants us to sketch something here. So this was actually going to be the most challenging one because you're going to have to draw something out here on these last couple problems, 7 and 8. But let's see how we would do that. It says sketch the solid produced by rotating the figure around the given axis. Then identify and describe the solid. So we have a rectangle here, and here's a line we're going to be seeing. This is our axis, and we're going to just kind of spin this. If you can think of rotating this around, spinning this shape around it, what kind of shape would that give us? And that's going to give us a cylinder. So if I spin it around, it's going to create a circle going this way, where this would be a radius of 4. The height of this cylinder would be 9 going around. On this one you have a triangle, and here's your axis right here. You have 2 going right here. If you spin this around, the shape that this will form is going to be a cone. So it'll be the cone. The radius would be 2. Height of the cone would be 5. And so that's going to happen. It's what that's going to be. So you're trying to do this. You're trying to sketch this and draw this out of what this would be. So 7 and 8, they look actually like almost the same exact. They are the exact same shape. Sketch the solid produced by rotating the figure around the given axis. So one is got an axis going this direction, so we're spinning it this way, and the other one's going to be spinning it this way. So this was more like an x-axis, one spinning over the x-axis, this one's spinning over the y-axis. So if we were to spin this, try to figure out what you would draw here. You're going to end up with circles on the top and the bottom, and so it's going to should look somewhat like a cone, but it won't have a tip on it, because if you were to extend this all the way out here and make that kind of a triangle, then it would be a cone. But since we went down here and you have another radius of 2 centimeters, it's kind of like if you slice off the top of a cone, you get the bottom half of a cone. Or you might want to think of it, it's also kind of the same as like one of those things that cheerleaders use with making their voice louder. I forget what those are called. kind of like a microphone, some kind of a microphone thing. But this one, you can see it'll look like this. So that's what I'm talking about there. It's kind of some kind of microphone thing to, you know, project your voice. And so that's what you need to try to draw here on this one, something similar to that. So see if you can draw that. This one, you're going to go around this way, so it's going to spin around. So 8 is going to be the radius. You're going to definitely have a radius here. This is going to be kind of a point at the top. So you have a point at the top there. So for this one, it's going to look like this. You know, so it'll definitely have a round shape here at the bottom, and then a point at the top. And you know what this is? This says the bottom section of a cone, which is what we were talking about. This one says a cone superimposed on a cylinder. So if we think about, if you draw a line from here to here, that would actually make a cone on the top and a cylinder on the bottom. A very wide cylinder at that, and a very wide cone. So it's like sticking a cone on top of a cylinder there. All right, so go ahead and, you know, just draw these out. Just finish drawing these out. If you need to pause the video so you can keep drawing these on your paper, go ahead and do that. But that concludes our 11.4 lesson, and you should be able to have no trouble with the assignment.